Okay, let's start. Example 18. Let's take a look at this question. Example 18 and 19 are the atypical type of question. It's not a very standard question, so pay close attention. Okay. You have a lambda here. Fine, you don't know what is lambda and a constant. Show that C has no stationary point. Now, a lot of things has been omitted. Has been printed for you, you don't have to copy. But again, like what I said, as long as it's printed, when I say look up, everybody look up, don't do their notes. Right? Now, when you want to show that there are no stationary points, of course, the first thing you do is to differentiate. I don't care how you do it, you should know how to do it. Differentiate this using quotient rule. Differentiate this expression using quotient rule. Okay? No problem. Just treat lambda as a constant. Maybe treat lambda as 10, 20, whatever, doesn't matter. Okay, I assume we can do it and you get this expression here. Now, you're going to show that if C has no stationary point, so it's an if, right? So you know they tell you C has no stationary point. So if C has no stationary point, what would it mean? dy dx not equals to 0 cannot be equal to 0. Very good. Which actually means that dy dx equals to 0 has no real solutions. Am I right? No real solutions cannot be equal to 0, correct? Fine. No real solutions. Now, cannot be equal to 0, so that means this numerator cannot be equal to 0. I don't care about the denominator. Correct? Yes? I don't worry about the denominator. So we say that the numerator equals to 0. This numerator equals to 0 has no real solutions. Okay, after you finish copying that line, everybody look up, okay? After you finish copying the line in blue, then you look up. Don't look down. Now, what does it mean for a quadratic equation in X to have no real solutions? Very good. B squared minus 4AC. So B squared minus 4AC less than 0. So this just means that if you want to copy, it would just mean discriminant less than 0. Okay? Then following that will be a series of solving inequalities, which you should be quite good at after the dark test last week. Right? Okay? So just, I don't care how you do it. Okay? Done. So you have shown this inequality. Okay, good. Okay, so you need to make use of solving your skill in solving inequality. Okay, now next part. The question asks, determine the equations of the asymptotes. Now you still don't know lambda. But shall we then take a look? Is this, look up. Is this proper or improper? Improper. So improper one is the first thing you do. Long division, excellent. So we do long division. It may look difficult, but it's actually not. So I assume we all can do it, okay? The thing that I want to highlight is this part. You're gonna divide lambda x squared plus 1. So make sure you leave a void here, you know, right? Okay. Alright, just make sure you leave this void here so that you can do a proper long division. Okay, so assume that we all can do it. Fine. Okay. Now, are we able to read all the equations of the asymptotes? Is it easy? Easy? Good. As x tends to infinity, this whole fraction tends to 0. So y tends to this. Looks complicated, but it's actually just a straight line. Okay, just an oblique asymptote. So your asymptote, one of the asymptote is this. What is the other asymptote? The vertical asymptote, which is quite easy as well. As x tends to -1, y tends to infinity. So x equals to -1 is a vertical asymptote. Done. Easy. Now, what is the so the question next? Draw a sketch for the case negative lambda between -1 to 0. So they tell you lambda between -1 and 0. So C has no stationary point. Okay. Now all look up, look up. Nothing to copy. All look up. Intersections with the axis. Now I sub x equals to 0. In here, I get y equals 1. Easy. Okay? I substitute y equals to 0 here. Maybe I substitute in the original form because before we did that, before we have that y, let's put it on the same page. Y is equals, before we did long division, it was this one, right? Correct? Correct? Before we did long division, it was this. So if y equals 0, the numerator must be 0. So numerator equals to 0. So I solve, I get x equals to plus minus square root what negative of lambda by a mouthful. Is it correct? Can I square root -1 over lambda? Yes or no? Think. Look up, don't look down, look up. Can we square root -1 over lambda? Some yes, some no. Yes. So don't be worried when you say, hey, I reject no, square negative number. Very tricky. You know what I'm saying? Why? Because lambda, look here, lambda is negative. So I can square root -1. Fine? Can? Okay? So there's no problem. Don't forget to take plus minus square root. I'm not going to write down. You can write your own notes, okay? So now we use GC. Okay, assume we use GC, okay? But how to use GC? We don't know lambda, right? Can we use GC? Can, of course we can. Just use the GC and you substitute any value between -1 to 0, maybe -0.5. What you get from the GC is just a shape. Don't trust the values. Get the shape out. So assuming we enter this lambda is -0.5 into your GC, we get this shape. Let's not forget, when we solve analytically, we have shown that there is no stationary point here. Which makes sense. Look, doesn't look like there are any stationary point, right? And then you have found asymptotes. You have one oblique asymptote and one vertical asymptote. All makes sense. So now your job is then to sketch this onto your page 18. Transfer what you see there, whatever that we have found, onto page 18. Okay, do it now, DIY. All found earlier for you, no problem. Always check that, of course you can transfer the shape, but let us not forget all your SIAS. Stationary point, any stationary point? No, obviously not. Your intercepts here, intercept here, intercept here. So, intercept here, intercept here, intercept here. Okay, this should be the negative, this should be the positive. A, asymptotes. Don't forget to label x equals -1, y equals to lambda x minus lambda. Okay, all in terms of lambda, not -0.5. Let's also be very careful. Some of us may somehow forget. Some of us may do this. I know this is Very bad. It should tend closer and closer to the asymptote. Don't have this kind of thing. Do you follow what I'm saying? Cannot. Here as well. So check your friends. Make sure you don't have that. It should tend closer and closer to the asymptotes, but not further away. Follow? Good. Okay. Next part. Last example. Okay, all look up. Nothing to copy from now. Okay, look up. This is everything in the notes. Very careful, huh? What do we mean by unseen graphs? Look up. With the help of GC, they can give you any complicated looking function and you should be able to sketch. Am I right? Right? The GC does it. So this is something that we have never seen before, but the GC can help us do it. So here is a skill now. Important thing is now here, there is a defined domain. X can only take between -3 and 3. When that happens, you must make sure that you label the endpoints. Okay? So let's do this together with your GC. Let's do this together. Make sure we can get what is required. So, okay, I've sketched this here. Okay. Now just make sure that your GC is in radian mode. When it's not mentioned, it's always in radian mode. Unless it's mentioned. So make sure it's in radian mode. You get this? How do we ensure that it lies between -3 and 3? Now you can see from your notes there is one keystroke there. You will divide here, but what I'm going to do a bit differently here. I'm going to go to window settings. I'm going to set between -3 to 3 because the question says X can only take between -3 and 3. Am I right? So I force the GC to only sketch from -3 to 3. Then I am going to zoom 0, which is a zoom fit. And the GC gives me this shape. And you should be able to reproduce this shape on your script, which is exactly what you see on your paper actually. But let's be very careful here. Now, when X is -3, what is the endpoint? So on your notes, how do we do it? Or look up. How do we do it? I will click trace once. And then I click -3, enter, I will get my y coordinate. So I know when X is -3, y is this. So can you correct the notes there? Can you make sure that you label this to 3SF rather than 3 decimal places? It must be 3SF, not 3 decimal places. Something wrong there. So please label this correctly. Do more I'm saying. X is -3, y is this. 3SF 00703. Okay? Yes, sir. And the other side, this here, when X is 3, what you need to do is you press 3 and then enter. You will get this to 3SF as well. Not difficult. Then we should also be able to find the minimum point here and maximum point there. I am not going to go through. You should be able to handle this. Follow? Can? So then you can get all these things by yourself. Not forgetting that X is 0, Y is 0. It should pass through the equation. The sign 0 is 0. No problem. Okay? Okay? Questions? Good? Okay, another way of doing it is really you can use the divide function. It's actually not divide, it's just a syntax whereby you tell the GC, I want to sketch this for X greater than -3 and X smaller than 3. Another way to do it. So if you key in this to your GC, the GC will truncate all the other parts of the curve. That means X smaller than -3, there's nothing. X greater than 3, there's nothing. Follow? Can? Oh, that's it. No more. Yeah. Thank you.